Thank you, Adam. So my name is Lister Stavely-Smith. I'm going to give an overview and a bit of an update on the ASCAP survey project, which itself consists of 3 sub-projects, Dingo, Flash, and Wallaby. Yeah, the co-lead of this project is Elaine Sadler. So why study neutral hydrogen with ASCAP? Well, neutral hydrogen informs our view of galaxies, their formation and evolution. It's sensitive to inflow from the intergalactic medium. It's sensitive to outflow from star formation regions and AGN, and is the means by which gas gets funneled into molecular clouds and stars. Particularly H1 is sensitive to environment, environmental effects and interactions between galaxies, which provide, which drive fuel into the centers of galaxies. So this is done with the Australian SK Pathfinder telescope. This telescope is in a radio quiet zone, one of the world's best radio quiet zones. Shall just take the opportunity to acknowledge the traditional owners of the telescope site, which are the Wadjuri-Yamaji people. It's a very different design from what the SK itself will be. It's very much a survey telescope and will very much have a life into the SK era as a telescope which provides sources for the more sensitive SK to look at. So just an overview of the ASCAP H1 surveys. The wedding cake starts with Wallaby, which is the nearby sort of all-sky survey, though not quite, as we'll see, quite shallow. Then Dingo, which is essentially tens of square degrees of sky, somewhat deeper out to redshift of 0.4, and Flash, which takes uses the advantage of background continuum sources to detect absorption along the line of sight from even quite small, low mass clouds and galaxies. So that's the wedding cake, and that's sorry about that buzzing noise online, but we're back to normal with a slightly different view. So the main, I didn't skip any slide, did I? So the main update from the last few weeks, in fact less than 2 months ago, was that the review of ASCAP Science survey project was concluded, and the result of that was an allocation of time to all ASCAP projects, and the 3 Astro 3D projects between them were allocated 13,000 hours, which is almost half of ASCAP's time, almost half of the observing time for the next 5 years. So that's some 100 petabytes of data, plus like a 10% allocation of the POSI supercomputer to process that data. So, you know, though we have been observing in a limited way for the past few years, this is the real allocation, which starts later this year, and this will be a real legacy for Astro 3D, because this will continue till at least 2027, and there's no reason why surveys with ASCAP would not continue after that. Okay, so current technical and personnel status. Technical status, the pilot surveys, as I said, are being concluded. 600 hours of time has been observed and mostly processed. The full survey, as I said, will hopefully be underway later this year. It's waiting really at this stage for the phase 2 of the POSI supercomputer upgrade, the so-called Cetonics phase 2 upgrade, which takes the machine to 50 petaflops. And lots, it's not so much the processing power that ASCAP needs, but the data handling ability. Currently, Astro 3D funds 5 postdoc researchers for across the project. Tristan Reynolds, who's here, Zhongwen Ri, who's online, Schombet, who's based in Germany but still funded by Astro 3D, Payne, who's talking next about Flash, and Aditya, who's also at Sydney University working on Flash. Using Ingrid's membership database, a fairly recent version of that database, you can see that the project consists of quite an interesting mixture of different types of investigator. We've already had, because of the pilot surveys, already had about 4 or 5 students coming through working on real ASCAP data, which has been great training. Currently, though, we only have 3 students working on ASCAP. So given that full surveys are going to be underway very shortly, if anyone in this room is considering working with a student or co-supervising a student starting later this year or next year, it's a really good opportunity to get involved with ASCAP, even if it's just in collaboration with other Astro 3D projects. So currently our main collaborations in Astro 3D, the ASCAP project mainly collaborates or writes papers with people in the SAMI project and Genesis project. I don't think there's been I can't think of a single ASCAP paper that hasn't had a theorist on board. And of course, data intensive astronomy. And I think although the timelines of SAMI and Wallaby Dingo didn't really match up in the end, I think as SAMI transitions to Hector, there will be a lot more collaboration in that between those projects. So just going a couple of slides on each of these sub-projects. Dingo's had a couple of publications recently, Schombert and Zhongwan. I'll just mention Zhongwan's recent paper, and that paper was, results from this paper were based only on I think less than 20 hours of data with a third of the ASCAP array. But he was able to, mainly that was done for technical reasons, but one thing he was able to do with even that small amount of data was, as you can see on the bottom right-hand corner, extend coverage through using H1 stacking of this gas fraction stellar mass plane by about a factor of 3 compared with previous stacking experiments using alpha and previous direct detection experiments with X gas. So, you know, that small amount of data can already reproduce what's been done before and extend it further into the low mass regime. So Jen will talk a little bit more about, not about Dingo, but about X gas and angular momentum later. Moving on to Flash. So James Allison, who was with us for a long time, together with Elaine and the rest of the Flash team, got this tremendous Flash survey design paper published. This was a real tour de force of a paper. Great work by James. Sorry to lose James. He's taken his talents and is now working on nuclear fusion in Oxford. So you know, we don't just train you in astronomy here. You can go and solve the world's energy problems after you've finished, if you want. So Luke Hain will talk about Flash in a minute, so really see Hain's talk, but this is a slide which demonstrates that the phase 2 ASCAP data is being processed just recently, and it's looking really good. No bandpass problems that I can see in this data, and the phase 1 data on the left-hand side, and the phase 2 data on the 2 right-hand columns match up very nicely. So that's all looking very good for Flash full survey commencement later this year. Moving on to Wallaby, I won't talk to these diagrams here because again, Tristan is talking after the break. But Wallaby pilot, the Wallaby pilot survey has been targeting overdensities, and therefore the interaction of the outer parts of galaxies with the cluster, the intercluster medium, both inside the virial and outside the virial radius, as you can see there. And again, also Adam Mortz will talk about clusters in a slightly different context. Some new work that's not yet published. This is Tamsin O'Byrne's work, who's a new master's student at ICRA UWA. So we've been looking at the whole collection of Wallaby galaxies found in the Hydra field. That's a 60 square degree field. Now, interestingly, if you take the galaxies that Wallaby detects, only between half and 2/3 of them are actually catalogued in to date, even in the very deep infrared catalogues from the various satellites and missions. But if you look closely at deep optical plates, most of the remaining objects do have an underlying optical galaxy, as you can see on the left-hand side here. Just perhaps the mass to light ratio is slightly higher than normal, but there's clearly a galaxy associated with that H1 detection on the left. But there are a significant number of galaxies, 6 that we found in this field, which don't seem to have any optical detection. The H1 detection looks fairly reliable, I mean, fairly close to the noise, but it passes the reliability criteria. We don't yet know if, well, one of these is definitely real because it actually lies, I think that one on the top right-hand corner, you can just see a bit of a fuzz to the right-hand side. That's actually a nearby galaxy. So there's a tidal interaction going on there. And so that's real, but it's not really a dark galaxy. It's just a tidal remnant. The other ones, we don't know. We need to do some follow-up observations. They're not the usual sort of dark galaxy that's predicted by simulations low mass. These are pretty high mass things, so possibly turn out to be false, but we're having a close look at those. And Bi-Cheng will talk on this somewhat related field of ultra diffuse galaxies, such as the image on the left later on. This is an interesting, I'll just end with this interesting work that we're also just about to submit for publication, illustrating how sensitive Wallaby is, or how sensitive H1 observations to the outer parts of galaxies, illustrates how environment is actually important for the evolution of galaxies, despite discussions yesterday. On the left-hand side there, you see a ROSAT image, X-ray image of the Vogel cluster, and you see this dwarf galaxy pair lying well outside the virial radius of the cluster. But even at that separation from the cluster center, there's a huge tidal and ram pressure interaction going on, which is seen for the first time in much more detail by the Wallaby image on the right-hand side, which shows the tidal bridge between the two galaxies. It shows the merging of these two galaxies as being prevented by the tidal influence of the Vogel cluster itself, and the cluster medium, although not directly detected by ROSAT or by the new eROSITA maps, is stripping all that extended gas away in that huge half megaparsec H1 tail. So it directly tells us about the influence of environment on the outer parts of galaxies, even well outside clusters themselves, especially dynamically young clusters. So I'll leave it there with a little summary here. So the ASCAP surveys are proving a powerful tool for galaxy studies. The full 5-year ASCAP program will commence later this year. Hopefully, quite a few results. We've published about 20 or 30 papers so far directly using ASCAP data, a lot more to come, of course. And I just finally mentioned that so with ASCAP, the process data is available straight away on CASDA, but we're also just about to release all the value-added data, the catalogs and the cutouts and the cubes and the velocity fields, and those will be put on CASDA, the Canadian Astronomy Data Center. And we've been talking with Richard about getting these uploaded to Data Central too. So talk with Karen Lee Waddell or Tristan for more details on that data release. Thank you.